For naming aromatic compounds, we will be starting with benzene, but the basic preference order that we have, that is carboxylic acids, esters, acid chlorides, this remains the same. This order we have already gone through in aliphatic, which remains same. The preference order of functional groups is not going to change, but certain ways in which we name will be altered in case of aromatic compounds. So we start with benzene. Benzene is C6H6. It has 6 carbons. And each carbon is attached to a hydrogen atom. Now if you observe, each carbon is going to have 3 bonds. The fourth bond of the carbon is delocalized pi electron cloud, which is generally written as a circle in the middle, or you can draw 3 alternate double bonds. So the condensed version of this structure is generally written like this. This is representing 6 carbons, and to each carbon 1 hydrogen is attached. So the formula will be C6H6. If we are going to substitute the hydrogen in benzene, since hydrogen is connected to carbon via single bond, say if I have this structure, this is not possible in chemistry because this particular carbon is going to have 5 bonds, which is not possible. So this goes out. You cannot have this structure. That means anything which is linked to benzene has to be linked via single bond. So if I have a Cl, I'll call it as chlorobenzene, or if I have a Br, I'll call it as a bromobenzene. All of these groups are connected to benzene via single bond. Nothing can get connected via double bond, because then carbon is going to have 5 bonds. Now, in case of benzene, there are some names which are very typical, which we have to go through. Now, you have CH3. This is connected to the ring via single bond. This is called as methyl benzene. Aromatic is preferred is preferred over aliphatic, so we call this as methyl benzene. Now, if this carbon is attached to the ring, this is called benzylic carbon. If it has 2 hydrogens and one any other group, but it can't be hydrogen, we'll be using the word benzyl. If you have a carbon, it is attached to one hydrogen, to any other groups but not hydrogen, we'll be using the word benzyl. And finally, if benzylic carbon has no hydrogen attached to it, we'll use the word benzo. So we have benzyl, benzyl, benzo. The methyl benzene that we just studied, this is also called toluene. So, but the IUPAC name in this case is methyl benzene. If I have 2 carbons over here, then I'll call it as ethyl benzene. Now we are going to basically focus on these 3. These are generally used in common names, but in certain IUPAC names, this logic is used I'll give you an example. Say COOH is acid. So we have this is the structure of carboxylic acid. In this case, if you observe, benzylic carbon, there is no hydrogen attached directly to this carbon. So we'll use the word benzo, which comes from this. For acid, we write oic acid. We'll cut the previous vowel. So this is called as benzoic acid, not benzenoic acid. So this benzoic acid term is coming from this logic. If benzylic carbon has no hydrogen attached to it, we use the word benzo. So again, we'll take an example. If you have CN, nitrile is actually C triple bond N. Again, benzylic carbon has no hydrogen attached to it. So we'll use the word benzo. For nitrile, we use nitrile. In this case, vowel is not going to get eliminated. So we simply call this as benzonitrile. So you don't have benzenitrile, you have benzonitrile. You have to understand how you get benzonitrile. This is coming from this. Now likewise, for acid chloride is the derivative of acid. It is C double bond O Cl. When acid chloride is preferred, we write benzoyl chloride. Now, if this is attached to the ring, the name will be benzoyl chloride. Other acid derivative is amide. So amide is C double bond O NH2. For amide, we write amide. Since this carbon has no hydrogen directly, it will be benzo. O will get cancelled. It is benzamide. So when you have ring CONH2, it is called benzamide. Likewise, if this carbon has one hydrogen attached to it, we call benzyl. This is only used, say, if you have it's an aldehyde, so one hydrogen is attached to carbon. We call this benzyl. For aldehyde we use al, but we don't have anything called benzylal in chemistry. This is simply called as benzaldehyde. So benzaldehyde would be ring CHO. This we are using the common name as it is as IUPAC name. Or if we have OH, this is not called as benzenol. We use the common name in this case and it is called as phenol. This is the only case where ring is preferred and it does not start with alphabet B, it starts with P. This is called as, the IUPAC name of this molecule is phenol. If you take ring NH2, this has no carbon, so that logic goes out. This is benzene. For amine we write amine. A is vowel, so E get cancel. We'll cancel out E. It becomes benzenamine. Benzenamine. It's a very common molecule. It is also termed as aniline. Now, these names we will just go through. If ring, it has COH, benzoic acid, CN, benzonitrile. If you have ring COCl, benzoyl chloride, benzamide. So all these are coming through the word benzo. If there is one H, we call it as benzyl, that is in common name, but in IUPAC, if it is CHO, we call it as benzaldehyde. This is called as phenol. This is called as benzenamine. Now, the preference order remains the same. So if I have multiple groups, say I have CHO, OH, NH2, all the three attached to the ring. Among these, aldehyde, alcohol and amine, aldehyde is preferred. So we'll leave these two. This is simply called as benzaldehyde. Now, the carbon to which CHO group is attached will be numbered 1 because CHO is most preferred. Now you can move clockwise or anti-clockwise, giving the other groups the lowest number. So if I go in clockwise direction, it will be 2, 3, 4. So we'll use the same logic, putting them in alphabetic order. So it will be 4 amino, 3 hydroxy benzaldehyde. In this case, either you move in clockwise or anti-clockwise direction so as to give other groups the lowest number. Let's take one more example. Let's say we have this is to be named. In this case, we have three groups: methyl, benzaldehyde, aldehyde, and acid. Among these, acid is most preferred. So we'll leave out aldehyde and methyl. Benzene ring with acid is called benzoic acid. So the end of the name will be benzoic acid. The carbon of the ring to which acid is directly connected will be numbered 1. Now you can move in clockwise or anti-clockwise direction. In this, anti-clockwise direction gives you the lowest number. So 3 and 4 you have two groups attached. Aldehyde, for aldehyde we write phenyl. For CH3 we write methyl. F precedes them. So first we write F. It will be 4 phenyl, 3 methyl benzoic acid. So the difference is in aliphatic naming, you either name from left to right or right to left. In aromatic, it is clockwise or anti-clockwise. Now, say we have two isomers. Isomer means they have same molecular formula. These two form the fundamental of naming. So this is very important. Now let's focus on the first structure. You have acid and C2H5 is ethyl. Acid is most preferred, so this is out. When acid is directly attached to the ring, you call it as benzoic acid. On second position, we have ethyl. So our name becomes 2-ethyl benzoic acid. In second case, you have acid, but this acid is not directly attached to benzene ring. So this ring will not be preferred. This is out. So you take, this is acid. Acid is most preferred, so this will be 1, this will be 2, and this will be 3. So the principal chain in this case has 3 carbons. So we write prop. There are single bond between carbons, so it will be propan, 1 oic acid, or simply propanoic acid. On the third carbon, you have ring. If ring is not preferred, we use the word phenyl. So it will be now if you look at both the structures, both contain acid, both contain beyond acid there's a ring and there are 2 carbons, but the names are very different. So the most fundamental logic of aromatic naming is to check whether the principal functional group is directly linked to benzene, like in this case this is directly linked, or it is linked to a side chain, like in this case it is not linked to benzene. If benzene is not preferred, we'll use the word phenyl. Just like you have ethyl, methyl, propyl, butyl, when ring is not preferred, we'll be using word phenyl. And lot of students make a mistake of confusing this with phenol. Phenol is totally different. Phenol is when you have OH attached to ring. We call it as phenol. This is not phenol, this is phenyl. Now, let's take one more example. Let's say we have now in this case, if we identify the groups, we have C double bond O, which is keto, you have ring, and you have amine. Among keto and amine, keto is preferred since keto cannot be attached to benzene ring directly because it has a double bond. Something can only attach to the ring by a single bond. This will also be out. Now keto is going to get the lowest number. That means we'll number it from our left to our right. So this will be 1, this will be 2, this will be 3, this will be 4, 5 and 6. So we write word root as hex. There is a double bond between 4 and 5. So hex 4 N 2. For keto we write on. So the end of the name will be hex 4 N 2 on. We have not written NH2, which will be starting with A amino, and ring, if it is not preferred, we write phenyl. So it will be 5 amino 3 phenyl. So the name of this organic molecule will be 5 amino 3 phenyl hex 4 N2 on. That means if the ring is present, it need not be something like benzene or benzaldehyde. It can be phenyl also. Phenyl is used when the ring is not preferred, when the principal functional group is not attached directly to the ring. Now, if you have this as a straight chain and you have CH3 which is not attached, which is not a member of the straight chain, we call this as this out group. This is called as methyl. Another set of organic molecules can have OCH3. This functional group is called ether. It is called as methoxy. Simply you have to remove YL and replace with OXY. So if you have ethyl, 2 carbons, and you have OC2H5, instead of writing ethyl, you will put it as ethoxy. Ethers are always written as prefixes. They are not written at the end, they are always written at the beginning. So if you have CH3, CH2, CH2, OCH3, this will be written as 1 methoxy propane. 1, 2, 3. This is methoxy. 3 carbons, prop, all single bonds, ane. 1 methoxy propane. Now, so if you have to name this, there are 4 groups which are attached to benzene ring: acid, nitrile, ether, and amine. This preference order has to be memorized. If you look at ethers, they are at the end, so they're normally not preferred. Acid is at the top. So in this case, we'll prefer the acid. So the end of the name is going to be benzoic acid. Now acid is attached to carbon, it becomes 1, 2, 3, 4. We are going clockwise so as to give them the lowest number. For CN, it is cyano, OCH3 methoxy, NH2 amino. So it will be 4 amino, 2 cyano, 3 methoxy. I hope this name is clear to you. Now, let's say name this. In this case, acid obviously is the most preferred. This is ring, this is oxygen with the ring, so this is ether. So this one is ether, this one is normal benzene ring which is attached. Since acid is most preferred and acid is not attached to the ring directly, we'll call this as phenyl. So if you number this, will be 1, 2, 3, 4. The end would be but, all single bonds between carbons. So ane oic acid. Since acid is always at the end, you may not write 1. If you're writing 1 also, then also it is correct. So it is butane 1-oic acid or butanoic acid. Now you're left with two things over here. One is directly ring, which is phenyl. O and ring, this will become YL, will get cancelled out, become phenoxy. So alphabetically O comes before Y. So it will be 2-phenoxy 3-phenyl butanoic acid. Now we will come to complexes. First of all, a complex would mean you have something, say this ring, this is not being preferred, and this also contains a functional group. So you have Br attached to this. So if something is not preferred, you have acid at the end of this chain. So obviously acid will be preferred, ring is not preferred, but ring contains a bromo also. So if something is not preferred and it contains a functional group, then it is termed as a complex. So we'll start with the naming of complexes. Let's say we have to name this. We will change this later on, but let's say we start with this one. So this contains acid, which is most preferred. So acid will be given number 1. This will be 2, 3, 4, 5, 6, 7. Hept, word root, ene, ane, ine. So this will be 3, ine, 1, oic acid. Hep 3, ine, 1, oic acid. We are left with benzene ring. C double bond O is, this is keto, this is alcohol and the ring. So alcohol starts with H, keto with O and ring with P. So first we have alcohol. So it will be 2-hydroxy 6-oxo 5-phenyl 2-hydroxy 6-oxo 5-phenyl hept 3-ine 1-oic acid. We are going to convert this into a complex. Let's say there is a Br which is attached over here. The entire naming would change. This has become a complex. Now, for a complex, you have to specify where this Br is attached on the ring also. That position has to be mentioned. Wherever the complex touches the principal chain, the most preferred group is still acid. This complex is touching this at 5th carbon. The first carbon of the complex will be numbered 1. Now you can go clockwise or anti-clockwise. So we go clockwise to give bromo the lowest number. So bromo will be at 3. So there will be two numberings. One is the numbering of the principal chain, which is till 7, which is going in this, and one is the numbering of the complex part to represent where that group is attached on the complex. Now when we are naming this, for complex we'll be using the first alphabet. So this case the name will be 5 3 bromophenyl 2 hydroxy 6 oxo hept 3 ine 1 oic acid. The end part, if you observe, it is absolutely same because our principal chain remains the same. We have written this bromophenyl before hydroxy because this starts with B now. We'll be using the first alphabet of the complex to decide the order of prefixes. This 5 is representing the position of the complex. The entire complex is written in one bracket so that it is, if I just simply write 3 bromo, you will feel bromo is attached over here. So it is one part. So it is written in the bracket 3 bromophenyl. You have to close the bracket after the complex finishes. Then remaining name remains as we already have done. Now we'll try one more. This time we are directly going to write the complex. Let's say we are supposed to name this. Now in this case, the most preferred group will be aldehyde. So this will be your order. Now if you observe on the fourth carbon, this ring is attached. If there was no chloro or bromo, I would have simply written as 4-phenyl. But in this case, on fourth carbon you have chloro and bromo. So this becomes a complex. Carbon of the ring which is directly touching the principal chain, this will become 1, 2, 3, 4. I hope you are understanding there are two numberings which are going on. One is for the principal chain and another is for the complex part. Now the complex part, the first alphabet would be bromo. It is phenyl, but it contains at fourth position bromo and third position chloro. So you'll use the same order. First you name B, then you name C. So it will be 4 bromo 3 chlorophenyl. That is the complex part. So this will be starting with B. This starts with A. This starts with H. So I'll be starting with A. Let's write the end first. It will be pent. All single bonds and 1 ul, or simply you can write ul. So it is pentanol or pentan 1 ul. This is the end of the name. Now we start with the prefix part. First we write A. So it will be 3 amino. The complex is at the fourth carbon. It starts with B. 4. Now 4 bromo. I hope you understand that the first four, this is representing the position of the complex, and the second four is representing the position of the bromo on the ring. So it will be 4 bromo, 3 chloro, phenyl, close the bracket. I don't have space, so I'm writing it over here. 2 hydroxy, pentane 1 al. This part you should be clear with. This is important. This is the complex part. Just go through it once. It will be 4 is representing the position of the complex and 4 bromo, 3 chloro, phenyl. We'll try one more example. Let's say we have pH, and on the ring you have OH. Now let's first identify all the functional groups. CONH2, it's an acid derivative, amide. C double bond O is keto and OH is alcohol. Amide, keto, alcohol, amide is most preferred. So 1, 2, 3, 4, 5, 6. The end of the name will be hex 2 ine 1 amide. When amide is preferred, we write amide, so it becomes hex 2 ine 1 amide. Now, if you observe on the 5th carbon you have ring, but this is not an ordinary ring, otherwise it would have been phenyl. It also contains an OH, so it becomes a complex. So for the numbering of the complex, the carbon which touches the principal, so this will be 1, 2, 3, 4. This is the phenyl on which on 4th carbon alcohol is present, which is not preferred, so we write hydroxy. Lot of students make a mistake of writing this as phenol. Use the word phenol when ring is preferred. In this case, ring is not preferred, so it will be phenyl, but this phenyl also contains an hydroxy. So your naming in this case would be 5 4-hydroxy phenyl 4-oxo hex 2 ine 1 amide. Now, if I simply add, say, a Br over here, then this 5 will remain same. So we'll say 3 bromo 4 hydroxy phenyl. Now say if I put NH2 over here, then you will have 2 amino. So basically you use the same logic. This will remain phenyl. Whatever extra is there, these groups, they'll be written in alphabetic order. So if these 3 are there, first I'll write amino, then I'll write bromo, then I'll write hydroxy. So this will remain phenyl with all these substituents. Now the complex can be present on a straight chain also. Let's take an example. Say we have This is a very simple name, so you will have 1, 2, 3. So this will be 3-ethyl benzoic acid. Now we will do some alterations to this. Let's say I remove this H and I put a Cl. Now this becomes a complex. This is a complex because this part is not preferred and it contains a chloro. Now we'll use the same logic. Wherever the carbon of the complex, the first carbon of the complex is touching the complex, touching the principal chain, that will become 1. This will be 2. So now if I name this, it will be 3 bracket 2 chloro ethyl, close the bracket, benzoic acid. If you observe the difference, in the first case it was not a complex. Second case, if we put a Cl over here, it becomes a complex. Now let's say we'll make one more variation. We remove this H and put a CH3 over here. So you have CH3. Now if you number the carbons, it will be 1, 2. This will become the third one. Now your name would be 3 2 chloro. Instead of ethyl, it will become propyl benzoic acid. Now we make one more change. Say we remove this H and put a CH3 over here. Now when I am numbering this, I cannot say 1, 2, 3 and jump to this as 4. You have to take the longest chain with the condition that this carbon, this one will always be 1. Try and make the longest chain. So again you will have 1, 2, 3. You cannot have 4 carbons in one chain. You cannot jump. So this is out. If CH3 is out, we write methyl. Now your name would be 3 2 chloro 1 methyl propyl benzoic acid. This will remain propyl. This is the propyl on which on second carbon you have chloro and on first carbon you have methyl. So I can keep on changing this. This can make, I can put an OH or any other group, but everything is going to come in front because acid is most preferred. So it will remain benzoic acid. Let's take one more example of this kind. Let's say if I have to name this, we'll first identify the group. CONH2 is amide, which is an acid derivative, which is most preferred in this case. And this is bromo. So the end of the name is benzamide. For amide we write benzamide, which I told you in the beginning of the lesson. Now this is 1, this is 2, this is 3, and this is 4. So at second position you have bromo. This is also fine, 2 bromo. But the upper part, this is a problem. Now the carbon which is touching the ring will be 1. If you try and make the longest chain, you cannot write this as 4-butyl, it will be wrong. This has to be 1. Now you try and make the longest chain, you cannot have 1, 2, 3, you cannot jump. So it will be 1, 2, 3. So this will be out. This is a complex now. So now your name will be 2-bromo, since it starts with B and the other one is going to start with M. 2-bromo 4 bracket 1-methyl propyl benzamide. You will not be putting this thing as butyl. It will be wrong because 4 carbons. You cannot say this is butyl because the carbon which is touching the ring has to be 1. So the longest you can make is only 3 carbons. 1 methyl will be left out and automatically it becomes a complex. Let's see one more example and then we will start with the next concept. Let's say one more example is if I have to name this alcohol, amine, chloro, alcohol is most preferred. So the end of the name will be phenol. There is no question about it. So you simply end it with phenol. This will be 1, this will be 2, this will be 3. On second carbon you have complex part. So this will be 1, this will be 2, this will be 3 and this will be 4. A, C. This is not a complex, but you have to write this. This starts with M. So we start with A. Complex is on second carbon, so it will be 2, 3 amino, 2 chloro, 4 carbons in one line, so you'll be using butyl, close the bracket, 3 methyl phenol. Please observe the complex part carefully. See if there is any doubt or any area which you are not able to understand. Now we'll see how we represent bond line. Say we have butane, which is CH3, CH2, CH2, CH3. In bond line, we can simply write butane like this. This indicates 1 carbon is here, 2, 3, 4. So bond line is basically a benzene if you are writing. Benzene, we do not represent any carbon or hydrogen, we simply write benzene like this. So this is bond line. So for aliphatic compounds also, say if I have this is representing 1, 2, 3, 4, 5. So there are 5 carbons, and on the third one you have OH. You can add the hydrogens, assuming carbon always forms 4 bonds. So the IUPAC name of this will be pent N3O. In your exams, instead of giving you a linear structure like this, a lot of times they will give you bond line. We'll try name one of the bond line structures. Say if we are given let's say we have to name this. So there are two ways, either you directly do on this one or you try and convert into a normal way we put in like this. I'll try in both the ways. First of all, C double bond is keto, so on this end 1, 2, 3, 4, 5, 6, 7. This is out. This simply indicates methyl. So you have 7 carbons, so it will be hept 4 N 2 O. That will be the end. So on 6 you have hydroxy, 3 you have methyl, so it will be 6 hydroxy, 3 methyl. Or what you can do, you can convert into a normal format. Say 1, 2, 3, 4. You make 4 carbons. Between these two there is a double bond, and this one, this is an OH. Then you have C, which has another CH3 attached to it. C double bond O CH3. 1, 2, 3, 4, 5, 6, 7. So this is the name. Some students are comfortable with bond line itself. If you are not, you can just change into a regular format and do it. So a lot of times these days exams will have naming which will be in bond line. So if you are given this, both ketones, so 1, 2, 3, 4, 5. Pent, all single bonds, N, ene, 2, 4, di, one. There are 2 ketones, so dione, 2 and 4, and it will be pentane 2, 4, dione. So bond line is a very simple way. If you are not able to do it, say if you want to change this one, it will be C, 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 double bond O, double bond O. Now you can name this. Hydrogens, if you attach or don't attach, do not affect the name. So if you don't attach hydrogen also, you can put this in rough and you can do the name. Okay, now we will come to some special names. First of all, we study about amines and amides. Amine is simply NH2, whereas amide is an acid derivative which is CONH2. So they can be, the hydrogens of the nitrogen can be substituted. So let's say we have to name this. So this will be simply prop N 1 amine. If you have NH2, it is an example of a primary amine. Now we replace one of the hydrogens with CH3, if you only have NH, it becomes an example of a secondary amine. Now if I am going to name this CH3 is not the part of the longest chain. NH2 is attached to this carbon, so this will be 1, this will be 2, this will be 3. This CH3 is attached to nitrogen, so you write it as N-methyl propane 1 amine. This capital N indicates attachment with nitrogen, and this is just used as a number. If there are two nitrogen, then you'll be using a comma, or there is a hyphen between M and N. So you just use this capital N as a number. Now let's say we'll just modify this slightly, and we have something like CH3, CH2, CH3N. If I were to write NH2, this would have been primary. If it was NH and something, it would have been secondary, but I'm writing both CH3s over here. So if you have an amine which is only N, there's no hydrogen with it, it becomes an example of a tertiary amine. Now this is the structure which we have just made is a tertiary amine. Now you will look at the longest chain through to which this nitrogen is attached. Obviously this is the one at the top. So we'll try and give the lowest number to N. So it will be 1, 2, 3, 4. So your name would be but and 2 amine, butane 2 amine. Now this nitrogen is attached to 2 methyls, so it will be N comma N dimethyl. I just told you use N just like a number. Now if instead of both being methyls, I'll just replace this with a ethyl. Let's say instead of methyl over here you have C2H5. Now this starts with M, it starts with E alphabetically, E will come first. So now the name will be N-ethyl, N-methyl, butane 2 amine. So you have amines which can be categorized as primary, secondary and tertiary. Same goes for amides also. Amides are basically CONH2. So if I replace this H with an alkyl group, it becomes secondary. If I replace the other H also, it becomes a tertiary. We'll try and name one amide. Let's say we have CH3, CH2, C double bond O, NH2. This is simply prop N, one amide, or you can simply write amide. So propan amide. Now if I replace this hydrogen with C2H5, now it will be named as N-ethyl propanamide. We replace the other hydrogen also. This has, let's say, a CH3 or Okay, CH3. So it becomes N-ethyl. Over here you will have N-methyl. This is an example of a tertiary amide. So amine and amides, a lot of times you will have N something. This N indicates attachment with nitrogen. Now we'll see the naming of esters. Before we start with the naming of esters, we will just see how they are formed. Now you have an acid. This is propanoic acid. This reacts with an alcohol. Let's say we take an example of methanol. When acids react with alcohol, you get esters. They'll be losing water. Acid always loses OH and alcohol will lose H. So your end product will be CH3, CH2, C double bond O, O, CH3. So this part which has C double bond O till this point, this comes from acid and this part is coming from an alcohol. General name or general formula for an ester is R C double bond O O R dash. This means this from acid and this part from alcohol. When you are naming an ester, the alcohol part is not preferred. So this will be written first and then you'll be writing the acid part. And esters end with O8. So general name of an ester is everything. In the start you have alkyl group, everything in the middle, and finally you will write O8. Now we'll try this one. This one we'll try. So you have alcohol is not preferred. So alcohol part has CH3 alkyl group. So you write methyl. There will be no 1, 2 or anything. Methyl space 1, 2, 3. Acid part is preferred. So 1, 2, 3. Prop and 108 or simply O8. So this is methyl propanoate. If I give you CH3, CH2, CH2, C double bond O, O, C2H5, you will be able to make out in this case that this part is coming from alcohol and this part is coming from acid. Alcohol part is not preferred, so it will be ethyl. This has 1, 2, 3, 4 carbons, so but, all single bonds and O8. You can write 108 also or simply O8. So it is ethyl butanoate. Now if I have some other functional group, say we'll take the same example of ethyl butanoate. And I replace one of the hydrogens. If you look, say this hydrogen has been replaced by a chloro. Now I have to name this. Alcohol will not be preferred, so name starts with ethyl. Everything in the middle and at the end you will have OH. So 1, 2, 3, 4. You will say 3 chloro but and OH. So in the beginning when I told you the generalized name, if you look at it, it is alkyl, which comes from an alcohol. Everything in the middle, whatever remains, and at the end you will write OH. We'll take one more example. We have CH3CH double bond C NH2 CH Cl C double bond O O CH3. Now you should be able to identify that this is ester, the end part is ester, and this is coming from an alcohol. This part is coming from an acid. Acid is preferred to 1, 2, 3, 4, 5. So we can simply say the C double bond O of the ester will be taken as 1. Now the name will start with methyl. No 1, nothing prefix, simply methyl. Now you start with the normal naming. You have written methyl, which comes from the alcohol. Now it will be on 3 you have amino, on 2 you have chloro. This is A, this is C, so A comes first. It will be 3 amino, 2 chloro, pent, 3 N, 1 OH or simply OH. Both are correct. So this will be your name. Alkyl, everything in the middle, and at the end you write OH. So in case of aromatic, we will take two examples. One is phenol reacting with acetic acid, and one is benzoic acid reacting with methanol. Both will give you esters. The structures are very close, but the name will be very different. As I've told you, alcohol loses H, acid loses OH, OH, H. The first one O, C double bond O, CH3. The generalized name is R, O, R dash. So you start from this and this will be R, C, O, O, R dash. Second case it will be ring, C double bond O, OCH3. You understand the difference between the two? Look at the structures very carefully. Now the alcohol part comes first. In this the alcohol is this one. So this one will be phenyl NO8. This is not preferred. This comes from an alcohol. This is phenyl eth, 2 carbons, and for ester you write OH. The second one, this is coming from an alcohol. So it will be methyl benzoate. If on benzene this carbon has no hydrogen, you write benzo, so it becomes methyl benzoate. The structures are very similar. In your exam they may give you the first one like this, OCOCH3. The second one is COOCH3. So very close, but the names are very different. Just go through them carefully. Now bond line, practice bond line thoroughly, because a lot of times these days names are coming through bond line. And Aromatic naming is very similar to aliphatic. The preference order and everything remains same. You have to memorize the preference order, but aromatic is slightly typical because you have benzaldehyde or phenol, those names have to be memorized. In case you have any doubts, you can ask me in the class, but if you watch these two videos thoroughly and carefully, you should be able to learn the naming well. Thank you.